And what is up, YouTube channel? All right, so today we're continuing once again the SAT Khan Academy problems, and I'm actually doing it from my parents' house. And so I'm in actually, this used to be my old bedroom, but not anymore. And I'm in here, so I'll be broadcasting from here. So again, we're going to walk through a new section today. It's going to be radical and rational equations from Khan Academy. And so usually these will be coming every day through the 5 days a week. Monday through Friday. I missed yesterday. I was traveling. So sorry, guys. But again, check back and you can see the whole library of these questions being solved to help you prepare for the SAT. If you're watching on Facebook, you won't be able to see the problems actually being solved, unfortunately. So if you want to see the problems being solved, click on the link in the description or go to my YouTube channel. Go to YouTube and search for Scalar Learning, and you can check it all out there. All right. Let's begin. So now on YouTube land, we're going to switch over to the screen share so we can see what I'm doing over here. All right, so now let's go ahead. And again, I haven't seen these problems yet, so this will be the first time. Radical and rational equations. And we're going to take a screenshot of this, and we will be doing everything, on the Wacom, using the Wacom tablet on a WAP, a web whiteboard. So let's go ahead and say desktop. Here we go. Boom, here is question number 1. So question number 1, it is 2 times the square root of 9x minus 6 equals 10 minus 2 times the square root of x. What is the value of x? First thing is we want to simplify this radical. We got to treat these radicals like variables, get them all together. So we can actually simplify this because we've got a 9 underneath that root symbol. We can add, and which is a perfect square. Whenever we got a perfect square, we can extract that, take the square root of it and pull it out. So I'm going to rewrite the equation as 2 times. We're going to pull this 9 out. This 9 is going to come out as a 3, okay, because the square root of 9 is 3. So 2 times 3 times the square root of x minus 6 equals 10 minus 2 root x, and we can't manipulate x there. Now let's multiply the 2 and the 3. We got 6 root x minus 6 equals 10 minus 2 square root x. We need the numbers on the same side and the square root of x's on the opposite side. Isolate the variable. I'm going to move the 6 over here. I'm going to move the 6 to the right side. So I'm going to add 6 to both sides, right? That's the principle behind variable isolation. Let's get rid of that. Now we have 6 square root x equals 10 plus 6 is 16 minus 2 root x. And then we got to move this guy over here. I'm going to do that by the opposite of subtraction. It's being subtracted. So we're going to add 2 root x, add 2 root x. So these guys, boom, they go away. Now we have 8 square root x equals 16. Now we're almost there. We can divide both sides by 8, because if we divide both sides by 8, we're going to cancel out this 8. And now we have the square root of x equals 16 divided by 8 is 2. Now what's the last step? Last step is we square both sides. That is the opposite of taking the square root. So we're going to unlock this x and just have x, not the square root of x. So we're going to unlock this. It's going to be x equals, what is 2 squared? That is 4. So here is our final answer, x equals 4. So we're going to plug that in, and let's see if they accept our work and our answer. And indeed they do. You can see they've kind of solved it the exact same way that we solved it. All right, let's go on to question number 2. Well, these are also ones that I like. I think when I did the last video, I mentioned how I like working with exponents and radicals. I don't know why, but I enjoy it. And so here we're doing some more prompts. Pretty cool. All right, let's go to this one right here. Okay. We got n plus 2 equals square root of a minus n. For what value of the constant a does the above equation have n equals 1 as the only solution? Okay, interesting. All this means is, all they're doing is plug in n equals 1 for this equation and solve. And then you're going to get your solve for a. That's all it is. It's not, it sounds confusing, but that's really it. So we're going to replace, well, let me rewrite the whole thing first. N plus 2 equals square root of a minus n. And then I'm going to plug in 1 for everywhere we have an n. Square root of a minus 1. Okay. This becomes 3 equals a minus 1 out. And the whole point of these problems is the way you get rid of the square root every time is you square. You square both sides. If you square both sides, squaring is the opposite of square rooting. Boom, then it vanishes, goes away. So now that we've got everything kind of the square root isolated, we just go ahead and square this, and we got to square this as well. This knocks out the square root symbol. Now we just have a minus 1 over here. On this side, we have 9. Okay. So now we're looking good. Now we got 9 over here. Let's just do our last step. We're going to add 1 to both sides. Add 1 to both sides. Goodbye. A equals 10. Oops. And that's our final answer. So we're going to go ahead and plug that in here and see how that turns out as well. Do they agree? They do. All right. Let's move on to the next question. Here we go. We've got, let's see here. Number 3. Usually these get harder as we go on. So let's see if that is the case. We got a, so again, it's this giant equation. What is the value of P, or what value of P is a solution to the above equation? Solving for P, that's it. It's 8 square root P minus 2 square root 3 equals square root 3 plus 3 square root P. Same idea. We need to bring these guys together, bring the square root P's together and isolate them. So I'm going to rewrite this equation. 8 square root P minus 2 square root 3 equals square root 3 plus 3 square root P. First, I'm going to subtract 3 square root P, subtract 3 square root P from both sides. Get them on the same side. These guys are opposites. They go away. You treat this square root P just like if it were a regular variable. So we got 8 of 1 minus 3 of the same thing, just becomes 5 square root P minus 2 square root 3 equals square root 3. Now let's move this guy over here, right? How do we do that? Since we're subtracting, we do the opposite. We're going to add 2 square root 3, add 2 square root 3. This goes away. And this is really 1 square root 3, by the way. There's no 1 there, but it's always there. It's invisible. There's nothing there. So 1 plus 2 equals, so let's write this whole thing out. 5 square root P equals 1 plus 2 equals 3 square root 3. Okay. Now we can divide both sides. Now you can kind of actually do it one of 2 ways. You can kind of leave it like this and square both sides, or we can square both sides after we divide by 5. It's up to you. Let's follow the way that we did it last time. Let's divide both sides by 5 first. Let's fully isolate this guy. Okay, and then goodbye. Now we have square root of P equals 3 over 5 times. You could put it in front or on top, either like I wrote here, it's on top. It doesn't matter. It's the same thing. Okay, whatever's more comfortable with you means the exact same thing. Still, it's multiplying the numerator here. Now, last thing, let's unlock this square root symbol by squaring. Same idea every time. We're going to square both sides. We're going to square both sides. Now we have a nice P all by itself. And this becomes 3 squared over 5 squared, which is 9 over 25, squaring numerator and denominator. And then squaring this square root 3. That just, again, takes away the square root symbol. And we just got a 3 left over. We could even put a 3 over 1. Let's complete this multiplication. And we've got P equals 9 times 3 over 25 times 1. 9 times 3 is 27 over 25. Now, sometimes you may have to reduce this, turn it into a mixed number, but we see right here in the answer, they provide 27 over 25. So we're good to go. I'm going to go ahead and answer that, see if that is indeed what they have chosen, and it is. Excellent. And if you're watching for the first time today, I always check. I always see. I never assume that I'm 100% right. I have made mistakes in the past. These are done live, and these are done with things that I haven't seen before. So I'm not perfect, pretty good, but I have and will continue to make mistakes here and there, I'm sure. All right, so now let's go and to number 4. We've got 4p to the 1/2 power. I'm going to explain what 1/2 means in a second, plus 5p equals 0. What is the least value of p that is a solution to the above equation? Why are they saying least value? Because there's going to probably be two values for p. Is my assumption. We'll see if that's true. Okay. So how do we solve this guy? This is a little bit interesting now. We got 4p to the 1/2 plus 5p. All right. So we can do it like this. I'm kind of trying to think about this. This is what I would do first. So let's go. We've got 4p to the 1/2 plus 5p equals 0. Guess what? 1/2 power, anything to the 1/2 power is just, it's the square root. It's the same thing, because with a fractional exponent, the numerator is the power you're raising it to, okay? And the denominator is the root, it's the radical. So this means it's going to the 1 power, which is nothing, same, it's just having the number itself, and then taking the second root, the square root. So this can be rewritten as 4 square root p plus 5p equals 0. Okay, so how do we want to play this? We can treat this as a quadratic equation, or we can kind of factor this as is. The way that we could do this, okay, is we can actually factor. See, I didn't actually think about this at the time, but now this just came to me looking at it now. We can actually factor this equation, and we can factor out a square root of p. Okay, now this will take a little bit of thinking as to why this is the case, but what's left here? Why can we do that? Well, if we have we're gonna have a 4 left here, right? So just a 4 left on with that first term, because it's like 4 times square root of p would just, if we multiplied this across, it would give us this again. That's why we're factoring it out. But what comes out here, that's the question. Definitely the 5 still stays in, and we're gonna have a square root of p here. So why is that? Equals 0. Because if we went through and multiplied the square root of p against the square root of p, a square root of a number times a square root of that same number ends up becoming p. So we would once again have 5p. And again, if you're watching on Facebook, make sure to click on the link, come to my YouTube channel, and watch the live stream so you can actually see the problems that I'm solving. So you not just hear what I'm doing, but you can actually watch the whiteboard. Okay, so now we have square root p. So now it's fully factored. And what does this mean? We have 2 values, okay? When we have something factored like this, we make 2 equations. Because if just square root of p becomes 0, this whole thing goes to 0, right? Because 0 times anything is 0. So we break it up. We're like square root of p equals 0. That's where we'll find one solution. The other solution is if this inside section equals 0. 4 plus 5 square root p equals 0. Now we just solve for p in both of these equations. And this one on the right, p just equals 0. Square root of p equals 0. P must be 0 for this to be true. So that's one solution, which is actually right here. And then this one we got to isolate, right? So we're going to subtract 4. We got 5 times square root of p equals -4. We're going to divide both sides by 5, divide both sides by 5. Now we have them right over here. Square root of p equals -4/5. And then we're going to square both sides again to get rid of this square root symbol. And we got p equals 16/25. There's a second answer. And so they said they want the lesser of the 2 values. Actually, this is kind of funny because 16/25, that simply is, oh, wait, hold on. Let me just make sure I did everything right here. 4 square root p, 4 plus 5 square root p, because this should actually be a negative value. Let me make sure this is right. Oh, no, it can't be a negative value because that would be square root. This second value is actually not even a good value. I just realized. Because what's happening here is this is an invalid solution. If you plug this back into up here, we would not get 1. This isn't one of those weird times where the second solution, oops, let me change that. This second solution is actually no good. 0, I think, actually is the answer. These negative values here, if we actually plug them into this equation, it almost makes sense that they would work, right? But if we actually plug them back in, we would get an imaginary number. Now this is 1, so I'm trying to think about this for a second. Is this actually another way we could have solved this? Is we could have been like, let me just try one other thing to make absolutely certain. Equals -5p. We could have done this. We could have squared both sides. We could have gotten 16p equals 25p squared. And then we could have divided both sides by 25, right? 25. And then divided both sides by p. That would go away, and that would go away. We have 16/25 equals p. Yeah, so that's the solution that we get if I did it. I just want to see if I did it a different way. So my hunch on this one is 0 is in fact really the only solution. There's no other solution, but as long as we're not using imaginary numbers and all that. So 0, let's go ahead and plug it in. Let's see. I don't know. I'm kind of feeling iffy. All right, so that is indeed correct. I didn't miss anything. Let me just look to see how they did it. Yeah, P 1/2, same thing. They did it the same way. And yeah, they're basically saying it's the same thing. They factored it the same way, and they said the only thing we can get is P = 0. So boom, feel good. That was a little tricky. Wasn't too sure. Now, let's go on to the next one here. Number 5. Gonna erase this guy. Here we go. Here we go. Last but not least, k equals this craziness. What are the possible values of k that satisfy the equation above? Now we are going to have multiple solutions. By one positive, one negative is my assumption. Let's see how it goes. So this is pretty interesting because, again, the main goal with solving this is first you must isolate the radical. All right, so what does that mean? K equals square root of 10 plus 3k minus 4. Let's isolate the radical, meaning move the 4 over. That's our first step. And now we have k plus 4 equals the square root of 10 plus 3k. Always isolate this guy so then we can square nice and easily and remove it. Okay, so we got to square this side and this side. This magically gets rid of the square root. We're just left with 10 plus 3k, and that's cool. The left side is more complicated because k plus 4 squared is actually this, k plus 4 times k plus 4, right? That's anything squared. It's it times itself. So now we got to do a little FOIL action. We got to do first, outer, inner, last. So k times k is k squared. K times 4 is 4k, plus again inner, which is 4k, plus last 4 times 4, which is 16, equals 10 plus 3k. We're going to add these two guys because they're like terms. We got k squared plus 8k plus 16 equals 10 plus 3k. What do we have? What is this? This is a quadratic equation. How do we solve quadratic equations? We get everything to one side, have it equal to 0, factor, and then solve. And by the way, if you're watching on Facebook, if you want to see the actual problems being solved, click on the link in the description. Go to my YouTube channel, and you can see the live stream. You can actually see the problems as I'm solving them. So then we gotta let's just move it all in one step. We're gonna subtract 3k and we're gonna subtract 10. I'm gonna put the 3k under here, just the like term. Subtract 10 under here. Those guys go away. Goodbye, goodbye. Now we have k squared plus, what's 8k minus 3k? That's 5k. 16 minus 10, what is that? That's 6, right? Plus 6 equals 0. Now we're in great position to factor this guy. So let's make a little room. I'm going to do it up here. So can we factor this? Maybe we can't. You never know, but I'm going to assume we can. I always try this first because it's the fastest. So we got k and k. And the question is, what multiplies to positive 6 adds to positive 5? That would be, 3 and 2 actually work. So it is factorable. So here are our two solutions that lie within these guys. Because basically now when either this or this quantity equals 0, we're good. So we have two equations, k plus 3 equals 0, k plus 2 equals 0. This one subtract 2 from both sides. K equals -2. This one we subtract 3 from both sides. K equals -3. Let me circle this. Let me circle this. Now remember I said my initial hunch was we get a positive and a negative, maybe like in choice D here, and 2 and -2. It was incorrect. We got -2 and -3. Let's make sure we are good to go. Let me check the answer. It's good to go. All right, so that's it. So those are our radical and rational equations. Let me come back here, and we're going to turn off the screen share. Oops, how do we do that? Oh, here we go. Stop sharing down here. Oh, where did my mouse go? Something is going crazy. Boom, stop sharing. Okay, what's up, guys? That was my first time doing a YouTube live stream from my laptop. So I hope that was okay. Didn't have my mic set up, so the audio might not have been that good, but we're going to have that all sorted out for the live stream tomorrow. And guys, on Facebook, again, hope you enjoyed. Hope you're able to click over to my YouTube channel and check out exactly what was going on so you can see the problems being solved. So again, check back Monday through Friday. We're going to be doing this live stream tackling 5 Khan Academy SAT problems. You can check out my previous Khan Academy question solving problems videos as well. I got a bunch of them already. So just to help you prepare for the SAT in the best and most efficient way possible. So that's it, guys. Thank you so much for joining. Have a great day.